Hi, Mr. Tating here. We are looking at our CP2B fall final review, and we're just looking at numbers 1 through 17 from your guys's your practice final here. So let's get right into it. A few things here. I'm not going to go over exactly. I'm going to basically look at it as how I would do these problems. Okay, there's some shortcuts I want to use because on the final you're going to be pressed for time a little bit, being that you have 2 hours. 50 problems in 2 hours shouldn't be too bad, but I'm not going to go over 5 different methods for each problem. Okay, so let's start at number 1 here. Get right into it. We are looking at factoring. Now what I see with the factoring here is that there's no coefficient. I shouldn't say that. There's a coefficient of 1 on the d squared. That means I can use my area and X marks a spot model, but I don't need to worry so much about the whole area model. I can go right to my diamond problem. I can take my negative 48, put it on the top here. Zoom in a little bit. I can take my negative 2 and put it at the bottom. Let me think here. What two numbers multiply to negative 48 and add to negative 2? That would be a 6 and an 8. So 8 times 6 is 48. If I make the 8 negative, we're okay there. Those negative 8 plus 6 is negative 2. That means I can go right to my factoring now of x. Oops, it's a d in this case. D minus 8 times D plus 6. That's your answer. Same idea on number 2. On number 2 here, we have a coefficient of 1 on the x squared. So I can go right to my diamond problem. My 10 on top, 7 on the bottom. What two numbers multiply to 10 and add to 7? It'd be 5 times 2. They're both positive. So we would have x plus 5 times x plus 2. And that is it for number 2. Number 3. Now we are going to have a little bit of issues here. We're going to want to use our area model, probably. So I'm going to go ahead and start an area model here. I'm going to put 7y squared here, negative 24 here. All right, get my calculator out. If I take 24 times 7, and calculators are allowed on the test. I'm also going to allow one note card, one 3x5 note card front and back. That's 168. So this multiplies to negative 168 y squared. So I can go ahead and do my x here, or my diamond problem. The negative 13 would go there. Now 168 is not an easy number to deal with here. So we're going to figure out what multiplies to 168. We already know that 24 times 7 does, but that's not going to work here. It also needs to add to 13, to negative 13. So let's do 168 divided by 21. 8. Well, that works. 21 times 8 is 168, and that will subtract to 13. So we'll go 21 times 8, and the 21's got to be negative. So now we can go back to our area model here. That means we're going to have, and that'll be a y and a y. So negative 21y, 8y. Right here, I know that a 7y can factor out of 7 and negative 21. Here, that's just going to be a y then, which means this has to be an 8 here. And then 8 times something gives me negative 24. That'd be a negative 3 here. So my final factoring should be 7y plus 8 times y minus 3. Now, here's the good news. Since it's going to be a multiple choice test, you could go through all of the answers and just multiply. Like if this is one of my answers, and let's say this appears one of my answers, I can multiply x times x is x squared, x times 2 is 2x, and keep on going until and see if I get our original equation here, original factor expression. So if I multiply this, 7y squared, that checks with right here. 8 times negative 3 is negative 24, that checks there. So then all I do is I check the outside, which is negative 21y, and the inside, which is 8y, and you can see that that multiplies a negative 13y. So you could work backwards just by looking at the answers, the A, B, C, D multiple choice answers. And that's one of the harder ones here. 4, same idea. We can factor here. So we can use our area model. So let's go right to this one. Should be a little bit easier, a little smaller numbers. 5x squared and 4. That is 20x squared. Put it in a diamond problem. Has to add a 21x. That would be 20 times 1. So 20x times 1x. 20x, 1x. And now I can take out of these two a 4. That means this is a 1. This has to be an x then, because 1 times x is 1x. And this has to be a 5x. So I have 5 times x is 5x squared, or 5x times x is 5x squared. And then we're finished there. Factoring here, I'll write right here actually, for 5x plus 1 times x plus 4. That's it. Okay, number 5. Let's change pen colors here. Let's go blue. So number 5, same idea. We're factoring this. Area model, 16x squared and 9. Multiply those together and I get 144 x squared. You can use a calculator for that if you'd like. And then it has to add a negative 24x. So add to that. And 144 is a 12 times 12, and that works out here. So negative 12x, negative 12x. Put those in my box. Okay, what can I take out of 12? 9. Well, 3 times 3 gives me 9. That also comes out of 12. And that means that something times 3 gives me negative 12x. So that should be a 4. Now, I'm looking here. 16x squared, I also see as a 4x times a 4x. I have to be a little careful here. because I have this negative 12. So one of these, either the 4x or the 3 has to be negative. And usually you make your constant numbers negative. And if I do that, I'm good because negative 3 times negative 3 is 9. So my final answer is 4x minus 3 times 4x minus 3, which you could also have 4x minus 3 quantity squared. Either one of those will work. Just look at the answers and in your multiple choice and figure out which one it is. Okay, 6, same idea. We're factoring. Go area model. When I see something like this, I actually see how, basic the numbers are, just an x squared and a 16. And I would look at the answers they give me and figure out which one multiplies to this x squared plus 16. But since we don't have those answers, I'm just working through your area model. You can always use those answers to try to use a shortcut, to find a shortcut. Trick here is since there's no x squared term here, that's just going to be a 0x. Now, a tough thing is the only things that can multiply to 16 would be 1 times 16, 4 times 4, and 8 times 2. Since this 16 is positive, they either have to be both negative or both positive. The only way I can add to 0 with these numbers here is if one of them's negative. So if it were negative 4, I'd be okay. The problem is those don't add to or multiply to positive 16x where they multiply to negative. So we can't factor it. So this one is non-factorable or cannot be factored. And that would be a possible answer in your multiple choice. Okay, 7's a little bit tricky. And 7's tricky because it says completely. This is the word we're looking at here, completely. That gives us a hint that there's probably something a number or an x that I can take out of each term there. So I'm looking at the 18, the 21, and the 6. And I see that I can take a 3 out of each one of those. I can divide a 3 out. So I'm going to divide a 3 out first. And also I see they all have x's. So I can take out or divide out a 3x. And that leaves me with 6x squared. And it should give you an x squared here. Plus 7x. 7 times 3 is 21. Plus 2. 3x times 2x is 6x. So we're taking out that 3x. I'm going to come over here because we have to write a area model now for what's left. So area model, 6x squared and a 2. That multiplies to 12x squared. Oops. Do that. My fault. Have to add to 7x, which would be a 4x times a 3x. So we can go 4x, 3x. Now we can see what we can take out of each row and column. I can take a 2 out of here, which means this has to be a 1, because 2 times a 1 is 2. 2 times what gives me 4x? 2x. 2x times what gives me 6x squared? 3x. And that should give me my final factoring. I still have that 3x out in front, but now I have a 2x plus 1 and a 3x plus 2. That's it there. Okay, that's pretty time consuming for those. Those are some of the more time consuming ones on here. Okay, we're looking at number 8 now. Tell whether the graph of the quadratic function negative 9x squared plus 3x plus 1 opens upward or downward. Explain. Let's change color. Just go to gray. I haven't used that yet. This one is actually a pretty quick one. Since that x squared coefficient is negative, it opens downward, or it's upside down. So it's a parabola here. Parabola opens downward because, oops, not becauser, becauser, not a word, because x squared coefficient is negative. Okay, 9, find the axis of symmetry. Okay, there's a few ways you can do this one. Now, what I would do is I would actually graph this. I would use the graphing calculator and graph it. So let's bring this in here. I'm going to go right to, let's see, I should bring it up here so you see the whole, what I'm typing in here. Turn on. So I'm going to go to y equals 2x squared minus 4x plus 4. I'm going to go ahead and go zoom, and 6 is standard. Zoom standard. Again, you have the benefit of the answers. So once I look at this, I can see the axis of symmetry, you can see my little pointer right here, runs right through here, which looks like it's at 1. So if I go through here and I see it's be x equals 1, if I can go through my answers and x equals 1 as an answer, I would just go ahead and go with that one because that's not, it's close. I would double check the other ones to make sure I don't have like an x equals 0.9, but I wouldn't do that to you here. So this one looks like we have x equals 1. So x equals 1. Pretty quick. Another way you can do it is if you factor this, this is actually pretty quick. I can factor a 2 out. I get 2 times x squared minus 2x plus 2. That might not work out very nicely because that's not going to factor nice. So the best way to do it is just use a calculator then. We could also use the quadratic formula and use that, or b squared minus 4, or b over 2a. So you can also actually do b, think about your quadratic formula, you can do negative b over 2a, which would give you negative 4 over 2 times 2. And that is 1. Right? So 2 times 2 is 4. Negative 4 over 4 is negative 1. Negative in front makes it a positive 1. So that's another way you can do it algebraically. Find the vertex of this parabola. You can actually do this the same way. You can use, I'll go backwards here. I'll go use the opposite of b over 2a. And that'll give you your x coordinate. So that would be negative, and then b is negative 20 over 2 times 2. So that would be 20 over 4, which is 5. So now my x is 5. That'd be my axis of symmetry. Now you plug the 5 into the x's here. And let's see, use a calculator here. That'd be, so this is 25 times 2, which is 50, minus 100. That's negative 50. So it should be negative 8. So your vertex would be at 5, comma, negative 8. Again, one thing you could always do is use your calculator. My y equals, clear that, just plug this in. 2x squared minus 20x plus 42. Zoom, I should push graph because I've already zoom standard it. And if I look over here, 1, 2, 3, 4, 5, and down 8. So that right there, that point right there is 5, negative 8. Okay, moving along here. Number 11, write the quadratic equation using the points from the following tables. Okay, remember, we need the x-intercepts. So there's an x-intercept, and here's an x-intercept, because the y is equal 0 right here and here. Okay, so now those give us our factors. Y equals x plus 3, we're going to do the opposite, and this would be x minus 2. And the last thing you got to check for is our y-intercept. If I multiply 3 times negative 2, I get negative 6. That's my y-intercept. And it checks here. If it doesn't check, we need to multiply, but I'm pretty sure on the test it's pretty straightforward like that one is. Okay. This one's pretty straightforward. Identify the vertex. Oh, they give it to us right here. So the vertex is 8, 1. I think they give it to you on the test. The bigger question is the minimum or maximum. Because it has a top, the maximum is the top here. So this is a maximum. And then the height is our y coordinate. So our maximum is at y equals 1. The minimum or maximum will always be y equals something, and it's either the top or the bottom. So it's always going to be that y coordinate. Okay, let's change colors again. Let's go to green. Find the zeros. The zeros from the graph are just the x-intercepts. That 0 is at 1, 0. That 0 is at negative 3, 0. That's it. Okay, we're going to some nice, easier ones. These are the last 4 problems, by the way, for today. The y-intercept, oh, the y-intercept's nice. This should say y equals. It doesn't say that. But that's our y-intercept right there. We've talked about that a lot, so that should be a pretty straightforward one. Graph this. Okay, so again, they're going to have multiple choice graphs. One thing I do know just by looking at it is it's going to be upside down. So it opens downward. I also know the y-intercept equals 0, 2. I could even find the vertex by using these, but I can use a calculator, so I might as well do that. So negative 2. Make sure you use that negative button down here when you enter this. If you use a minus sign, it's going to give you an error. Negative 2x squared minus 4x plus 2 graph And you can see there's our y-intercept at 2, and it opens downward. It looks like it goes up to like 1, 2, 3, about 4-ish. And at -1 here. So we can do a quick sketch here of this. Looks like I went through there. But on the test, oh, that might be a little too big, but that's all right. Quick sketch. On the test, it'll be multiple choice, so you can just select the one that has these two things, and you should be good. Solve this by graphing the related function. What that means is you want to find the x-intercepts. Okay, so if we graph this, it's number 16. Let's clear that, go there. So we have x squared minus 8x plus 15 graph. Now what I'm looking for are these 2 points here. Okay, that looks like the point 3, 0. I'll show you how you can double check that in a second. So a good guesstimation is 3, 0, 4, 5, 0. Okay, now if you look at these, if I multiply these together, 3 times 5, that's 15. If I add them together, I get 8. And that's a hint that you're right. Okay. It just says solve the equation, so your final answer would be x equals 3, x equals 5. And the whole idea here is, since it says where does that equation equal 0, if I look at this, here is the graph of my equation, x squared minus 8x plus 15, and it equals 0, which is our x-axis. Where does it cross that 0? That's 0 at 3 and 5. Okay, and last one, a kicker starts a football game by kicking off the quadratic function. So imagine we have this parabola that goes, ooh, it's a kick. Our football is going to land somewhere. That's my beautiful football. Over here. Okay. The quadratic function models the football's height after x seconds. How long is the football in the air? So what I want to know is, where does this x equal 0? Because it starts at 0 before the ball's kicked, and it lands back here on the ground. I draw a little axis here, right there. That's where it lands. So that's where x equals 0. Okay, so let's go ahead and graph this. So notice we're using the graph calculator a good amount right now. We're going to graph y equals negative 16x squared plus 52x. Now here's the thing, if I graph this in standard mode, I'm not sure what I'm going to see. So you do get a decent graph. It goes higher than 10 feet is the problem, assuming that y, yes, the y is the height, so it goes higher than 10 feet. So we can actually change the window a little bit. You wouldn't have to, because right here is where it hits the x-axis, but I like to see my whole parabola. So I'm going to change my height, which is my y max. I'll change it to 20 feet. Now let's go 30 feet in the air and see if I see the whole thing yet. Oh, I don't. My window. I also can change my min. Since my x is my time, I'm not going to go negative seconds. So I'm starting that at 0. I'll change my feet in the air to 50 feet in the air. There we go. So now I'm going from 0 to 10 seconds, and I'm going from this negative 10 to 50 feet in the air. So I want to know what this point is right here. Okay, so what I'm going to do here is, it looks like it's 1, 2, 3 point something, 3.1, 3.2. But I can do second calc, and that's 0, and go left until I push left until there's a cursor, until it's above that point. Push enter. Go right of it until it's below that point. Enter. Push guess. Push enter. So it's 3.25. So this is at 0, and this was at 3.25. That's my graph right there. Okay, so that is the first 17 questions of our final. A lot today. I think it's a little smaller. A few side notes here for those of you who are still tuning in. Okay. Graphing calculators. Okay. And also, one 3x5 note card can be used, and you can use the front and the back for your quadratic formula, maybe your trig functions. Okay. We will talk to you tomorrow.